Welcome back, class. Today we're looking at section 6.2, transforming quadratic functions. In other words, we're going to take our parent function, which is y equals x squared, and we're going to move that parabola around our grid. One of the ways that we'll move our parabola around is by using this equation. G of x equals a times the quantity of x minus h squared plus k. So that g of x is just a transformation of what we saw in our previous lesson, which is f of x equals ax squared. A is our scale factor. And we have new letters in our formula. We have h and k. H and k. H and k represents the coordinates of our new vertex. Now if we look at f of x does not have an h and k, which means that our vertex is at 0, 0. And just a few reminders from last time. If a, which is our scale factor, is positive, the graph opens up. If our a value is negative, the graph is going to open down. If a is between -1 to 1, then our parabola is going to be really wide. So a would have to be a fraction or a decimal. Between -1 to 1. If it's not between -1 to 1, then the parabola is not going to be wide. So for example, 1.5 would not create a wide parabola. 1.1 is not a wide parabola. A wide parabola would be when a is 0.5, 0.75, 0.99, 0.85, 8/10, 4/5, -1/5. Notice how all of those numbers are between -1 to 1. A narrow parabola is when a is less than -1 or when a is bigger than 1. So the parabola is narrow when a is less than -1 or bigger than 1. So a few examples of what a can be would be -6, -6.75, -1.1, 1.1, 3 1/2, 5 1/3. So I'm just making these numbers up. And notice how all of these numbers are either less than -1 or bigger than 1, which in return would make our parabola narrow. If a is 1, then we have what's called a regular size parabola. So the letter k will move the parabola either up or down. And go ahead and put this as number 8. H will move the parabola right or left. What's tricky about H is that you are going to be graphing the opposite of what you see, and we'll get into that later. So let's look at explain 1a. Graph the quadratic function, give the minimum or maximum value, and the axis of symmetry. We have f of x equals x squared. So let's go ahead and graph that. We did that in our last lesson, and because we're a little more familiar with how to graph f of x equals x squared, I'll go ahead and just make a 2-column table. And I'm using -2, -1, 0, 1, 2 because my a value is 1 and it's not a fraction. When x equals -2, I'll get y equals -2 squared. And -2 squared is 4. So my first point is at -2, 4. When x equals -1, we'll get -1 squared. -1 squared is 1. So my second point is at -1, 1. When x equals 0, y will equal 0 squared. 0 squared is 0. When x equals 1, y will equal 1 squared, which is 1. So my fourth point is at 1, 1. And when x equals 2, y will equal 2 squared, which is 4. So my last point is at 2, 4. And notice how all my points are symmetrical, which is exactly what we want. Now I'm going to draw my curve. And I'm going to label my graph f of x. In f of x, I know that my vertex is at 0, 0. And because the parabola opens up, I have a minimum value at y equals 0. It's always the y value of the vertex. So my minimum is at y equals 0. And in regards to the axis of symmetry is going to be the line that cuts our parabola in half. My axis of symmetry is at x equals 0. Now let's take our parabola and graph g of x by using transformations. So g of x equals x squared plus 2. Let's rewrite this in vertex form. Vertex form is the equation we saw earlier with g of x. And in case you forgot what vertex form is, let's write it down. So g of x equals a times x minus h squared plus k. This is vertex form. Now let's take g of x and rewrite it into vertex form. Vertex form, we have g of x is equal to x squared. We can rewrite x squared as x minus 0 squared. And the plus 2 that's not inside of the parentheses, that's going to go outside, plus 2. So the minus 0 will determine how many units we go to the left or the right. And that plus 2 is going to determine how many units we're going. In this case, because it's positive, we're going to be going 2 units up. So the minus 0 tells us we're not moving left or right, but that plus 2 means that we are moving 2 units up. So we're going to take every single point on f of x and just move them 2 units up. That's going to give us g of x. 1, 2. Let's take -1, 1 and move that 2 units up. 1, 2. Move the 0, 0, 2 units up. 1, 2. The 1, 1, 2 units up. 1, 2. 2, 4, move that 2 units up. 1, 2. And if you want to make a table to graph g of x, that's perfectly okay. Now let's identify the key parts of g of x. And I'll go ahead and highlight g of x in teal. The vertex is at 0, 2. X is 0, y is 2. G of x opens up, which means that we are going to have a minimum. It's a minimum because our vertex is the lowest point. Our minimum is at y equals 2, because that's the lowest y value. The axis of symmetry for g of x also happens to be x equals 0. And these are the key parts of g of x. Now let's move on to another problem. Explain 1b. Graph the quadratic function, give the minimum or maximum value, and the axis of symmetry. For this problem, I want to find all the key parts of just g of x. So let's graph g of x by using transformations again. We know f of x equals x squared is, you can make the table, or you can refer back to the previous problem, or you can just memorize the table. When x equals -2, y will equal -2 squared, which is 4. When x equals -1, y will equal -1 squared, which is 1. When x equals 0, y will equal 0 squared, which is 0. When x equals 1, y will equal 1 squared, which is 1. And when x equals 2, y will equal 2 squared, which is 4. So your y values for f of x equals x squared will always be 4, 1, 0, 1, 4. Let's plot our points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Draw the curve. Label the graph f of x equals x squared. Now we need to graph g of x, and g of x is equal to x squared minus 5. Let's rewrite g of x in vertex form. Vertex form class, it's g of x equals a times x minus h squared plus k. So if I rewrite this, that minus 5 is not in parentheses, so that minus 5 is going to go outside. G of x equals, that's going to give me x minus 0 squared minus 5. X minus 0 is the same thing as x. So x minus 0 squared minus 5. Okay, so that minus 0 is going to tell us whether or not we're moving left or right. And then that minus 5, because it's outside of the parentheses and it's negative, it's telling us to move the graph 5 units down. So for left or right, it says 0. We're not moving left or right. But we are going to move all of our points 5 units down. So let's start off with -2, 4, and take that point and just move it 5 units down. 1, 2, 3, 4, 5. Take this point right here and move it 5 units down. 1, 2, 3, 4, 5. Take the vertex 0, 0 and move that 5 units down. 1, 2, 3, 4, 5. Take 1, 1 and move that 5 units down. 1, 2, 3, 4, 5. Take the last point and move that 5 units down. Remember, the points should be symmetrical. Now let's graph the parabola. Highlight it. Label it g of x. That's g of x equals x squared minus 5. Let's label the parts of g of x. For g of x, the vertex is at 0, negative 5. The x value of our vertex is 0, the y value is negative 5. Because our parabola opens up, our vertex becomes the minimum point, and our minimum y value is at negative 5. The axis of symmetry is the line that cuts our parabola in half, and the line that divides it in half is at x equals 0. Okay class, that's part 1 of section 6.2. If you like this video, go ahead and give it a thumbs up and make sure you subscribe.